Hello and welcome to Math IPREP Part 4 Practice Problems. So in this video, we're going to go over a worksheet, and that worksheet is going to cover polynomials, including terms, parabolas, quadratics, end behavior, vertices, x-intercepts, and graphing. As well as at the very end, we'll cover the FOIL method. So first, let's start with section 1, quadratics. So first we'll talk about terms. So a polynomial is an expression with two or more terms with at least one variable raised to a different exponent. The terms are separated with addition or subtraction after combining like terms. So we went over this already in the lecture video, but as we can see here, we have this polynomial with 5xy squared minus 3x plus 5y to the third minus 3, and that has 4 terms. Let's also work through some practice problems. We're going to identify how many terms are in each of the following polynomials. So here we have x plus 3. So 1, 2. All right, now we have 3x squared minus 7. Once again, we have 2. X plus 8. 2 again. 4x minus 4. 2. 4x squared minus 4x plus 3. That's going to be 3 this time, right? And what about 3x to the third plus 2x squared plus x plus 2? How many is that? 4. What about 3x squared plus 5x minus 2? 3. What about 2x to the fourth plus 3x? 2, right? 4x squared minus 8. Again, 2. What about 4x squared minus 4? 2 again. About 8x squared plus 3x plus 2x5 plus 3. It's going to be 4. What about this one? We have x. It's going to be 1 term. X plus 2. 2 terms. What about 5x plus 3y? Once again, we have 2 terms. What about y plus 3 minus 6x? We have 3 terms. And finally, we have 4x to the third plus 2x to the 8th plus 25 plus 30x. And that is 4 terms. So that is terms, and that's how we count those up. So next we'll go over the quadratic equation. So we'll do this pretty briefly because we did go over all of this in our lecture, but quadratic equations are a special type of polynomial with only one unknown variable, and there is one instance of that unknown being raised to the second power. And the standard form of this equation is written as follows. Ax squared plus bx plus c is equal to 0. So quadratic equations are graph like parabolas, and these look like giant U shapes. When you solve a quadratic equation, you are solving for the x-intercepts. Some quadratic equations will have one solution if the parabola touches the x-axis, some will have 2 if it crosses the x-axis, and some will have none if it's above or below the x-axis. So to understand how to graph an equation, we keep the following in mind. So this equation right here, f of x is equal to ax minus h2 plus k. We use that to find this other one down here, which is what we're actually going to use. We have h is equal to negative b over 2a, where hk is our vertex. And we plug in b and a for that, but we'll come back to that. So a larger a value, remember we have ax squared plus bx plus c. So the larger the a value, the thinner the parabola is. The smaller it is, the wider. A negative a value will flip the parabola upside down. And then you must place your x-intercepts at the correct location, and the parabola must go through all of them. So here is going to be an example. So we have x squared plus 10x plus 24 is equal to f of x. So when we solve for x squared plus 10x plus 24, we get x plus 6 and x plus 4. We get that through factoring. And this means our x-intercepts are negative 6 and negative 4. So when we graph this, we have negative 6, negative 4. And here we have negative 6, negative 4. So then we solve for h equals negative b over 2a, we plug that in. Then we solve for k just by plugging in our h value to our equation, x squared plus 10x plus negative 5. And when we get that, we get negative 5, negative 1, and there's that. So as we can see, the width is the same as the parent function because a is equal to 1. So a right here, right, it's 1x squared. The x-intercepts and vertex, as we saw, we calculated them and graphed them, and our line goes through all 3 of those points. So let's go ahead and get some practice. So first we'll look at this first one. We have x squared plus 15x plus 56 equals 0. So when we're looking at this, how can we factor x squared plus 15x plus 56? So what two numbers add to 15 and multiply to 56? We have 7 and 8, right? So we're going to have x plus 7. I'll do a little better. X plus 7. X plus 8. So that means our x-intercepts are negative 7 and negative 8. So then we have to find our vertex, right? And we get this from our old equation. H is equal to negative b over 2a. So we have b is going to be 15, so we have negative 15. A is going to be 1, so over 2 times 1 is equal to 2. So we have negative 15 over 2, and that is our x value, right? So we have negative 15 over 2. And then to get our y value, we have to plug this back into our original equation, x squared plus 15x plus 56. So we do that, we have negative 15 over 2 squared plus 15 times negative 15 over 2 plus 56 is equal to 0. So when we solve for that, we're going to get, sorry, it's not equal to 0, it's equal to k, right? And so when we solve for k, what we get is k is equal to negative 1/4. So what we have is negative 15/2 and negative 1/4. And if we think about this, negative 15/2 is going to be right in between negative 7 and negative 8. So let's go ahead and put all this together. We have our vertex here. We have our x-intercepts here. And we can graph. So first, we can go ahead. And what we'll do is we'll start our graph way over here because we know our points that we know are negative 7, 0, negative 8, 0, and negative 15/2, negative 1/4. So we know most of our graphs are going to take place on the left side of our axis, right? So if this is going to be our 0 value, most of our stuff is going to take place on the left. I'm going to go ahead and put one right here. And then all we have to do is graph our values. So first we have our x-intercepts. So we have negative 7, 0. So 1, 2, 3, 4, 5, 6, 7. And we have negative 8, 0, which is going to be right next to it. Next, we have to graph our vertex, which is negative 15/2, which is right in between them. Negative 1/4, so it's going to be right here about. And all we have to do is just connect this graph. So over here. All right, so this is a rough sketch of what this would look like. And this isn't going to give you perfect examples and perfect results. But when you go through this method, you're definitely going to get some nice sketches that you can use. And when you use a graphing calculator, it's going to look pretty much just like this. So let's go ahead and move on to part B. So here we have x squared minus 18x plus 81 is equal to 0. So first thing we can do is find those x-intercepts by factoring, right? So what two numbers add to negative 18 but multiply to 81? And the answer we get is going to be -9. So we have x minus 9 and x minus 9. -9 times -9 is 81. -9 plus -9 is -18. So there we have our x-intercepts. We have +9 and +9. So we only have one intercept, 9, 0. And as we talked about earlier, if we have one intercept, that means it's only going to touch the x-axis. It's not going to cross it. And you'll see what that means in just a little bit. So next we can go over our vertex, which remember is h is equal to -b over 2a. So -b is -18. So then we have +18 over 2a. A is 1. So 2 times 1 is 2. 18 over 2 is equal to 9. So then we plug 9 into our equation. What do we get? We get 0, right? Because we can plug it in here. 9 minus 9 is 0. 9 minus 9 is 0. So our vertex is also going to be 9, 0. So now we have a little bit of a pickle, right? Because we have all these points, but in reality, we only have one point. So what we need to do is find another point next to it. So let's go ahead and plug in something like 10. So we have 10, we could plug it in here. So we have 10 squared minus 18 times 10 plus 81. And when we solve for that, what do we get? So 10 squared is 100, minus 18 times 10 is 180, plus 81 is going to be 1. So now we have a point of 10, 1. And because of how parabolas work, we know that they're symmetrical. If we go, so we went 1 to the right of 9 and went up 1. We know that if we go 1 to the left, we'll also just go up by 1. So now we have 3 different points to graph. So let's go ahead and see what this looks like. So this time we're going to have our graph be set a little bit differently, right? To the left of this time, because we know our values are a little bit higher. So first, we have our x-intercepts and our vertex, which are at 9, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so that is red for our x-intercept, but it's also yellow for our vertex. Then we have our extra points that we just calculated. So we have 10, 1 and 8, 1. Now we can go ahead and connect those points. So as we talked about, right, with that one x-intercept, it only kind of bounces off the line, right? It doesn't cross through it. It just bounces off of it. So that is a rough sketch of what part B would look like. So let's go ahead and move on to part C. So the last one we're going to do, and then we'll move on to the second half of our video. So here we have x squared minus 14x plus 48. So in this problem, how can we factor? What two numbers add up to -14, but multiply to 48? So here we have x minus 6 and x minus 8. Because these multiply to positive 48, they add to -14. So then we know our x-intercepts are 6, 0 and 8, 0. So next we just need to find our vertex. Which we get by h is equal to -b over 2a. It's equal to 14 over 2, equal to 7. And then we just plug 7 into here. So what is f of 7? It's going to equal 1, right? Because we have 7 squared, 49, minus 14 times 7, which is 98, plus 48. That comes back up to 1. So our vertex is 7. Now we have our points. We can go ahead and graph that out, right? So first, we can draw our lines. Thicker. And then we just have to graph our points, right? So our x-intercepts are 6 and 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. If our vertex at 7, should say -1, sorry. And then we just have to connect our graph. And it's not great. It's a rough sketch, but it is going to give you a good general idea of what it looks like. So that is the end of the first half, and now we'll move on to the next part. So now we'll talk about complex polynomials. So complex polynomials have to do with our vertices, our end behavior, our x-intercepts, and graphing. So to sketch a polynomial, you have to find all of those things. So first we'll start with vertices. So the degree of the expression will help determine how many vertices there are. So remember that the degree of an expression is the highest exponent in that expression. So here we have x squared. So that is the degree of 2. So to find the vertices, you do your degree minus 1. So here it's 2 minus 1 equals 1. So we'll have 1 vertice. So next, oh, and sorry, just to be clear, we find the absolute value of that largest exponent. So if it's a negative number, we make it positive. Cool. So next we have negative 4x squared. So this is the degree of 2. So we have 1 vertice. Next we have 4x5 minus 16x4 plus 12x3. What's our largest number? We have 5. So a degree of 5 minus 1 equals 4. Next, we have x3 plus x2 plus x. So we have x3 minus 1 equals 2. Now we have 4x squared minus 16. What's 2 minus 1? There's 1. And then the same thing on the next one. Here we have 28x4 minus 40 plus 3 minus 2x5 minus 9 minus 2x5. So here, make sure we're careful, right? So our degree is actually 5. It's not going to be 4, even though it's the first one. It's not the largest, right? So it's 5. So it's 5 minus 1, 4. Next, we have negative 144x to the 6th plus 3x to the 8th minus 6x to the 7th. So here we have 8. 8 minus 1 is 7. What about this one? We have x. What is our degree? It's 1. So 1 minus 1 is equal to 0 vertices. We have an exponent of 7, degree of 7, or sorry, an exponent of 8 and a degree of 8. So therefore we have 7 vertices. 0 again, 7, and 3. So now we'll move on to polynomial end behavior. So polynomial end behavior. So when we're looking at end behavior, we have some rules to look at. So if the polynomial has a degree that's even and the leading coefficient is positive, then both ends of the sketch are up. If the degree is even and the leading coefficient is negative, they both go down. So we have down, or sorry, up, up. This one's down and down. This one, if the degree is odd and the leading coefficient is positive, the left side is down, the right side is up. If the degree is odd and the leading coefficient is negative, the left side is up and the right side is down. So those are the rules that we work with. And now we'll go ahead and see what those look like in action. So explain the end behavior of the following expressions using these rules. So first we look at our degree. It's 2, so that's even. Our leading coefficient, is it positive or negative? It's positive. So we know this one, they're both going to go up because we have a positive leading coefficient and an even degree. What about this one? Our degree is even. Is our leading coefficient positive or negative? It's negative, right? So these are both going to go down. So next we have 4x to the 5th plus minus 16x to the 4th plus 12x to the 3rd. So here, degree of 5, coefficient of 4. So that's an odd degree and a positive coefficient. So up here, degree is odd, coefficient is negative, left side down, right side up. All right, so you're going to see pretty quickly that we can tell a lot about these graphs just purely based on the equations themselves. You don't even have to graph it out, right? Just looking at it, we can already tell how many vertices we have, the end behavior. And as you'll see in a minute, we can kind of figure out those x-intercepts pretty easily. And as we have been doing this whole time. Cool. So here we have a degree that is 3, which is odd, positive coefficient, because we have a coefficient of 1. So if it's odd and the coefficient's positive, then the left side's down, right side is up. And we have 4x squared minus 16. It's going to be both up. 4x squared minus 4. It's going to be the same thing. Next, we have 28x to the 4th minus 40 plus 3 minus 2x5 minus 9 minus 2x5. So here we have to combine like terms, right? So we have negative 2x5. We combine those, we get negative 4x to the 5th. And then we can see what we're working with. So we have an odd coefficient or an odd degree and a negative coefficient. So the left side will be up and the right side will be down. Next, we have negative 144x6 plus 3x to the 8th minus 6x to the 7th. So we have positive 3 and 8, which means both sides will go up. Next, we have negative 3x to the 8th plus 768. So we have an even degree, but a negative coefficient. So both sides will go down. Then we have 2x to the 4th plus 8x squared. So we have an even degree, positive coefficient. Both sides will go up. So that is end behavior, and we'll keep going with these rules. And if you notice, these are the same equations we just did for vertices, and we're going to keep these equations as we keep going. So now we'll work on our x-intercepts for these same equations. So this time we're only going to work on a few. We're going to do B, C, D, E, H, and I. And then we're going to graph B, C, D, and E. So let's go ahead and look at B. We have negative 4x squared plus 4. So in this case, how do we find our x-intercepts? So we can factor out the 4, right? Negative 4 actually. So we'd have x squared minus 1. And here we can factor our x-intercepts are going to equal 1 and negative 1. All right, because 1 squared is equal to 1. Negative squared 1, or negative 1 squared is also equal to 1. So we get 1, negative 1. So C, we can kind of factor the same way. So we can get x to the 3rd, and we can get 4 factored out. So 4x to the 3. And what we're left with is, let's see, x squared minus 4x plus 3. So now we can see we have 1 here with 0, or sorry, not there. 1 here, we have x equals 0. And when we factor here, we get x plus 1, or sorry, x minus 1 and x minus 3. Which means our x-intercepts are positive 1 and positive 3. So we have 0, 1, and 3. I'll go ahead and write these down as we go. It'll help you a lot when we get to the graphing section, if you remember and already have all of our answers kind of written down and ready to go. Cool. So next we'll do part D. So we have x to the 3rd plus 2x squared plus x. So we factor out x. We have x squared plus 2x plus 1. Here we can see it's going to be x plus 1 times x plus 1, which gives us an answer of 0 and an answer of negative 1. So those are our 2 x-intercepts for part D. We'll go ahead and work on part E. So we have 4x squared minus 4. We get 4 out of there. So we have x squared minus 4. That can factor 2x minus 2, x plus 2. So we see our x-intercepts are 2 and -2. Well, next we can work on part H. So we have -144x6 plus 3x8 minus 6x7. So we can factor out 6x3 and we can factor out 3. When we do that, we can rearrange it. So we'll get x squared minus 2x minus, what's 144 divided by 3? 48. And out here we have 3x to the 6th. So no one of our answers is 0. Then we'll have to factor this. So what multiplies to -2x, or sorry, adds to -2, but multiplies to -48? We have x minus 8, x plus 6. And we do that, we get +8 and -6. So those are our 3 answers for H. Let's go ahead and do one more. 2x4 plus 8x squared. We can take out 2x squared, which leaves us with x squared plus 4, which we can go into x minus 2. Ooh, wait. So this actually wouldn't work. We'd have to do -2x minus 4, right? Because then this can be x minus 2, x plus 2. Gotcha. So this one's kind of weird, right? Because we have to take out -2x, because x squared plus 4, we can't factor, right? It wouldn't work. But x squared minus 4, we can absolutely factor. So then we're left with 0, 2, and -2. So this one's kind of a weird one, but it is good that we went over that, because you can see sometimes you have to take out a -2 or a negative something, even if there's not a negative in your original equation. So now let's go ahead and sketch some polynomials. So first we'll sketch B. So here we have -4x squared plus 4. If you remember, this means we have one vertice or one vertex. If you remember our end behavior for this, both sides will go down. If you remember our x-intercepts for this, we have 1 and -1. So now let's go ahead and graph this. And if you can see right now, this is actually going to be a parabola, right? Or a quadratic equation. So we can also calculate the vertex. So B in this case is equal to 0. Right? Because we have no x, so we have 0x is equal to 0. A is equal to -4. So if H is equal to -b over 2a, then it's equal to 0, right? Because we have 0 on top. And then we can just plug 0 back into here, and we get 4. So 0, 4 is going to be our vertex. And our x-intercepts are going to be 1 and -1. So now we can definitely graph that, right? We have this here. We have 0, 1, 2, 3, 4. So about there. Our x-intercepts are 0, 1, 0, -1. We have our 1 vertex, right? And we know our end behavior goes down. So we have 1 vertex, we have our x-intercepts, and we have our end behavior. So this is a good sketch. So now we'll go ahead and do a couple more. So let's work on C. So if you remember from C, we have an odd degree and a positive coefficient. So our left side will go down, our right side will go up. vertices, we have a degree of 5, so we have 4 vertices. And then if you remember our x-intercepts here, on part C, we have 0, 1, and 3. And now we can just kind of graph from what we know. So we can draw our lines. We know we have x-intercepts at 0, 1, and 3. So we skip 2, right? 0, 1, 3. Now we have 4 vertices. And we come in from the bottom left and end at the top right. So let's go from here. So we'll go does that look right? It might not be. Let's see, we have only 2 vertices, right? So maybe this is not quite right. Maybe it looks something like that. Of course, this is just a guess, right? Because we don't know what exact coordinates of our vertices are. But we can definitely kind of guess, right? So if we look at our vertices, we have 1, 2, 3, 4 vertices. We have our x-intercepts. We have our end behavior. So this would be a good sketch. And again, it might not look exactly like this, but it will be kind of like this. All right, so let's go ahead and move on to part D. So in part D, we have x cubed plus 2x plus x. So how many vertices do we have? 2 vertices. What type of end behavior will we have? If you guys remember, going to have left down, right up. We have an odd and a positive. And our x-intercepts for D were 0 and -1. And now we can just kind of go ahead and try to graph this. So we know we have y-intercepts at 0 and -1. We know we have 2 vertices. So if we go ahead and graph this, let's see what it looks like. So we know we have to come in from the bottom left. All right. So is it possible it looks like this? Let's go ahead and check. So do we have 2 vertices? 1, 2. Check. Is our end behavior good? We have bottom left, top right. Check. And do we hit our y-intercepts at 0 and -1? Check. So this is a pretty good sketch as well because we hit all the boxes. And remember, this is just a rough sketch. It doesn't have to be perfect. Let's go ahead and do one more. So we'll do E together. So in E, if you remember, what's our end behavior or how many vertices we have? Our degree is 2, so we have 1 vertex. Our end behavior, we have an even degree, a positive coefficient, which means both sides are going to go up. If it's a parabola with 1 vertex, we know that means that it bounces off of our x-axis, and we'll come back to that in a minute though. And E from our x-intercepts, oh sorry, that's not what that means. 1 vertex just means it's a parabola. I'm so sorry. Our x-intercepts are 1 and -1, which tells us it doesn't bounce. It goes through, right? Because we have 2 x-intercepts. If we only had 1, then it would bounce. But we have 2, so it'll go through. And then we just go ahead and sketch this out. So first we have x-intercepts at 0, 1, 0, -1. We know both sides have to go up, so to start from our top left. And we get something like that. And we check it, do we have 1 vertex? Yep. Do the both go up? Yep. -1 and +1, yep. So that is a pretty good sketch of what it should look like. So now we'll finish out by going through binomials. So multiplying binomials. A binomial is a polynomial with only 2 terms. So x squared plus 3 is an example of a binomial. Another example is x squared plus 6. So you can multiply binomials together. So to do this, you have to do something called distribution. And this falls under the term FOIL. So what FOIL stands for is first, outer, inner, and then last. So we do x times x, and then we do x times 6, and then 3 times x, and then 3 times 6. When we would do all that, we get these 4 answers. We combine our like terms, and we get a final answer of x squared plus 9x plus 18. So let's go ahead and do a couple problems. So on this page, we're going to do A through F. And then we'll move on to a couple more complex ones on the next page. So first we have A. So we do FOIL. So we have x times x is equal to x squared. So we have FOIL. Next we do outside. So x times 2 is 2x. We do inside, 3 times x. And then we do last, so 3 times 2. 3 times 2 is 6, right? And then all we have to do is combine our like terms. So x squared, 2x and 3x combined to 5x. And 6. So that is our final answer. So let's go ahead and try it again for the next one. This time I won't draw the lines, but I'll leave those top ones on so you can see them. So this one we're going to do in blue. So first we have x times x, which is our first. Then the O in FOIL outside. So we have x times 8, so plus 8x. Then we do inside, so we have 5 times x plus 5x. Then we do last, 5 times 8, which is going to be 40. So what we're left with is x squared plus 13x plus 40. Cool, let's do part C. So part C, we have x plus 4 and x minus 9. So first we do first, so we have x squared. We do outside, x times minus 9, so we have minus 9x. And inside, 4 times 6 plus 4x. Then we have plus 4 minus minus 9 as our last. It's going to be minus 36. We can combine our like terms. So negative 9 and plus 4 combine to negative 5. So we have x squared minus 5x minus 36. Let's move on to part D. In part D, we have x plus 1 times x plus 1. So first we do first, so x times x, x2, outside times, so outside x times 1 plus x, inside 1 times x plus x, and last 1 times 1 plus 1. So here we get x squared plus 2x plus 1. Cool. So next we will do part E. So in part E, we have x plus 2 times x plus 4. So first, x times x. X squared. Outside, x times 4. Inside, 2 times x. Outside, 2 times 4. Or sorry, last 2 times 4 plus 8. We do this, we get x squared plus 6x plus 8. Cool. So now we'll do f. So when you see f, right, you see this squared, that means we can expand this, right? It means it's x plus 2 times x plus 2. So x plus 2, x plus 2. And then we can do our FOIL method. So first we have x times x. Outside, x2 times 2. inside x times 2, last 2 times 2. So we get equals x squared plus 4x plus 4. So that is A through F. Now we'll go ahead to the second page and we'll do some that are a little bit more complicated. We're going to do R through W. So do R. Something like that. So let's go ahead and start with R. So R we have first, we have x squared times x. So we'll have x3. We do outside, x2 times 3, 3x squared. Inside, 4 times x. And last, 4 times 3. So in this one, you see, we do not have any like terms to combine, right? We have x to the third, 3x squared, 4x, and 12. None of those will combine. So that is our final answer. So move on to the next one. We have x plus 4 times x squared minus 2. So first, we have x times x squared. So it'll give us our x3. And then we have outside x minus 2, so minus 2x. Inside, 4x squared plus 4x squared. And last, 4 times negative 2, minus 8. So you could reorganize this in the middle, right? If you'd like. So that it's in order of our highest exponents, right? So it goes 3, 2, 1, 0. So in that case, it would be plus 4x squared minus 2x. And that's the final answer for that one. Next, we'll do t. So we have x squared plus 3 times x to the third plus 8. So first, we do x squared times x3. So that's x5. And then we do outside, so x squared plus 8, so plus 8x squared. We do inside, 3x to the third. And then we do last, so which is 3 times 8. Once again, we have no like terms to combine. So on the next one, we have x squared minus 3 times x3 minus 3. So first, x squared times x3, x5. Outside, so x squared minus 3, so minus 3x squared. So inside, minus 3x cubed. And then minus 3 minus negative 3 is positive 9. Let's do the next one. So we have 2x squared minus 1 times x to the third minus 2. So first, 2x squared minus x to the third. Going to be 2x to the fifth. Outside, 2x squared minus 2 minus 4x squared. Inside, we have minus x to the third. And last, we have 1 times negative 2, which would be positive 2. Cool. Now let's do our last one. We have x squared plus 3 times 4x squared minus 4. So first, we have 4x squared times x squared. So we'll have 4x to the fourth. And inside, we have 4x squared times 3, so plus 12x squared. Sorry, 4x this 4x squared times 3. Sorry, so 12x squared. And then we do. I'm sorry, I skipped outside. So outside is x squared minus 4. Oh, I confused that last one up a little bit, huh? So if we look at this again, on outside on green, we have negative 1 and negative 2. Or sorry, 2x squared and negative 2. So it's minus 4x squared. I guess it's the same. But yeah, anyways, back to this one. So we have first 4x squared outside minus 4x squared. inside plus 12x squared, and last 3 times -4 minus 12. And this one, we actually do have combined like terms, right? We have these right here. So we'll come up with 4x4 plus 8x squared minus 12. So those are all of our example problems. That is the end of Math IPREP Part 4. Thank you for joining us. If you've been through all the videos, congratulations, you made through all 8. We're very excited that you watched these videos, and hopefully they kind of helped understand some of the concepts that you'll be seeing in your math courses in your classes. So thank you for participating and being a part of Math IPREP at CU Denver, and have a wonderful day.